and biomolecular engineering. She has won numerous awards for her research leadership. Her work examines the fate and transformation of environmental contaminants in our natural and engineered environments, and developed advanced wastewater treatment technologies. So I would ask you to applaud our guest.
Yes, please.
And then since I'm speaking at the podium, do I still need this?
Yes, because
Okay.
we've got this one.
Great. All right. Good morning, everyone. Everyone can hear me okay?
Yes.
And then hopefully everyone that's watching online can hear me all right as well. First, I want to thank you all for having me here today. My name is Kristin Hall. I'm the Executive Director for the Cuyahoga Soil and Water Conservation District. So today, a few things that I'm going to talk about are a little bit of just quick background on soil and water conservation districts. I know I'm newer to my role. I've been here just under a year, and I have learned so much about soil and water districts, what they do, and how they really help improve water quality throughout our country, really. I'm going to briefly talk a little bit about water quality in Cleveland and Cuyahoga County. And I think many of you in this room are pretty familiar with some of our region's history around some of these issues and some of the environmental issues that they caused. But then, really want to focus on then what Cuyahoga Soil and Water is doing, our different programs around education, watersheds, community involvement, and then more of the technical side on stormwater management, construction projects, those kinds of things. And then finally, I'm going to wrap it up with a few things that you can do. And I think some of that we'll also touch on during the Q&A section as well. So I have a number of slides. I talk kind of quick. I'm going to run through it sort of fast because I also want to make sure I leave plenty of time for Judy to work through her presentation, and then of course the Q&A as well. So really quick, I'm just curious, how many of you know how many soil and water conservation districts are in the state of Ohio?
Guessing 88.
88, we got it. We have, that is correct. We have one in every county in Ohio. So they may look a little bit different. Obviously here in Cuyahoga County, we are a much bigger community. We are a more urbanized community. So a lot of our focus is around sort of stormwater and local tree canopy, local native plants, those kinds of things. As you get away from Cuyahoga County, of course, it gets more rural. Their focus is more agriculture and making sure some of the runoff from those agriculture activities don't go into our waters. So soil and water conservation districts actually were formed from following the Dust Bowl. So of course, you may not necessarily remember this, but the Dust Bowl led to, we were doing a lot of farming in sort of the middle of the country, and we had really depleted our soils, and that had led to tons of dust that eventually was even getting blown, far east as far as Washington, D.C. And that really brought a lot of attention. Unfortunately, it takes events like this to draw attention to some of the problems that we have, and that's when conservation districts, it wasn't until about 1937 that the first ones were launched, but our district was formed in 1949, and we've been working ever since on a number of different topics that way. We also partner with, through our work, and this is not only in Cuyahoga County, but all of our districts, with a lot of different agencies here in Ohio. From the Ohio Department of Agriculture, we get about half of our budget from them. The Ohio Environmental Protection Agency, we work very closely with them in some of our day-to-day work, and the Natural Resource Conservation Service around some of the agriculture. And of course, we're figuring out what urban agriculture looks like for us as well. So my slide got a little messed up here. This is supposed to say water quality in Cleveland and Cuyahoga County with a beautiful picture of the city. We'll keep moving on from there. So obviously, I'm not, this is probably not news to anybody. Cleveland has a very strong industrial past, And with that, we didn't really take great care of our waterways. It was really easy to just push your stuff out into the river and then it goes away. And that's fine if maybe one person does it. But when we have multiple manufacturers just putting all of their pollutants into our water, we end up with pictures like this, where you're dipping your hand in, it's coming out as a sludge. They said the river oozes rather than flows. And of course, I think we're all familiar with the Cuyahoga River fires that then resulted from some of that. I like to point out that the Cuyahoga River, the one in 1969 was the biggest, but we did have 13 fires throughout the history of the river. But Cuyahoga is not the only river that had fires either. We just got all of the national attention. And while we don't necessarily love that in our history, I think we're really starting to see a transformation, because that river fire that brought that national attention to these environmental issues is what led to things like the Clean Water Act being passed in 1972. Mayor Carl Stokes, going to Washington and speaking on behalf of communities, especially disadvantaged communities that were really severely impacted by this. I mentioned the National Pollution Discharge Elimination System. I'm going to come back to that in a little bit, but really that's working to address those different points that the pollution is coming from, either from a factory or from perhaps runoff on the street. And then, the Cuyahoga River was designated as an area of concern in the 1980s, and we're now the facilitating organization for that group, and I'll get to that in a sec. So what we do at the district. We talked about the different types of pollution. You'll see on the left here, we've got point source pollution, and then we've got on the right non-point source. And I'll point out the point source is really easy. You can point to it. You can say, this is where it comes from. You can stick a bucket underneath it, take what's coming out of it and measure what kind of pollutants are going into our water. It's a lot easier to regulate that. The non-point source on the right is a little tougher because you have a lot of different sources of pollution. You've got your cars, you've got salt from the roads, you've got animal waste, litter, even fertilizer on the grass, and all of it is running into your catch basin. So it's really hard for us to know, oh, it was your dog that did it. It was that piece of litter. It's a collective effort. So a lot of our work is around more of the non-point source side of things, because we really want to try to help folks understand that whatever happens in your landscape is going to impact your water. So I mentioned that NPDS, National Pollution Discharge Elimination System. Each community in Cuyahoga County has a permit with the state of Ohio to put only so much pollutants from their water runoff into our waterways. So there's 6 different what we call minimum control measures. And I think just from the vibe I've gotten from this group, you'll appreciate that these are minimum control measures. We could do so much more, but we're really trying to get kind of the basics again, so that we're meeting the permit requirements as well. The couple that we focus on at the district are the public education and public involvement. We switch them around. We call them public involvement, public education, or PIPE. And then the construction site runoff, both during active construction, but also afterwards. And I'll talk about those in a quick sec. This is kind of a laundry list of our programs here. I'm not going to go through all of them because I will touch on a few of these when we get to the things that you can do. But we do a lot with watersheds, education. We go into classrooms and work with different student groups, stream cleanups, workshops, rain barrels, rain gardens, tree plantings and giveaways. We've got several $100,000 stream restoration projects that are underway. So we do quite a bit. Like I said, I'm newer to my role, and I've been very, very impressed with the volume and variety of work that we do at the district. It's pretty awesome. And then I also mentioned sort of that construction side. So imagine that we are going to build a new building somewhere. Anything that's over an acre needs to have some kind of stormwater control. Because if you think about it, if you're digging up an acre of dirt, when it rains, that dirt is going to go somewhere. It's going to turn into mud, and it's going to run into the nearest catch basin or stream that it can find. And then if you're doing construction work, that may also have debris, it may have cement runoff. There's all kinds of things that can be impacted from those projects. And then on the flip side, once that project's done, you also need somewhere for that water to go. If you've dug up an acre of dirt that had trees and grass and other things that were sort of soaking that up, you put in a building, it now needs somewhere to go. So you may see things like detention basins or bioswales that help control some of that. Our role is doing some inspections of both the construction site work that's managing the stormwater during the construction, but then also on the flip side, the post-construction, making sure that those basins and things are working correctly so that they are ultimately helping support our water quality and not backing up and flooding residents' basements and other waterways and things. So, you know, you can see some pictures here of some of the work that we do. You'll see on this right-hand picture, this is a silt fence. I'm sure any construction project you drive by, and hopefully now, maybe as you drive by them safely, keep your eyes on the road, but you may notice some of these, or maybe those big garden socks along, say, they might be surrounding a catch basin or the whole perimeter of a site. The one in the middle is for trucks. So, you know, trucks are driving across some of these big muddy sites. They need to kind of run over these in order to get the mud off before they go out onto our streets. Because once it leaves the site, then it's still just as likely to go into our catch basins. And then, you know, here's some of the examples on the right here of some of the more long-term control measures that you may see in like a housing development or something to manage the water after we have these heavy rain events. I mentioned briefly the Cuyahoga Area River of Concern. Soil and Water is the facilitating organization for this. We have a committee of about 25 members representing, you know, different stakeholders and some members of the public. And we're really working to get the river delisted as an area of concern. So basically taken off and saying that we've met all of our different criteria. You can kind of see a little timeline here. But the main thing to get us delisted is working on these, what we call beneficial use impairments. So we've had 4 that have been removed so far: fish consumption, public access, eutrophication of algae, which I know Judy is going to talk about a little bit here, and degradation of aesthetics. So all of those we have addressed and been able to show that we have seen improvement since 1987 when it was sort of first listed. We still have a number of BUIs that need to be removed, and we have some challenges here in an urban area to do that. So we're looking pretty good on the fish tumors and deformities, but beach closings, I think many of you are familiar with some of the sewer issues we have here, and we can get into that in some of the Q&A if we need to, but those are something that for us, it's going to be hard because the data isn't meeting the criteria that we need it to. But we have done with these big tunnels are being built, and we still have lots of other sources. Going back to that non-point source, there's lots of other things that are contributing to, say, the E. coli that we're seeing during those CSO events. So we are trying to make sure that we paint the right picture when we send our information to EPA. So and try to do our best in an urban environment and find that balance. So, you know, we're really excited that we are starting to see things move from burning water to a river system that really allows for not only, you know, people to enjoy it, but it's supporting our natural life as well, and really trying to find more balance with nature as opposed to trying to make nature do what we need it to do as people. So I want to talk a little bit about what you can do, just a few things. And I unfortunately, and I'm sorry, Ken, I forgot to bring some extra material. I left it at the office on Friday, but I'm happy to circle back and share information and resources if you do want to get involved sort of after this. So, you know, I gave you sort of that laundry list of our different programs. We have things like rain barrel workshops. You can sign up for our different pledges. So we've got a pledge here where you can get a coffee mug, and a coffee mug is all you really, of salt, is all you really need to sidewalk 250 square feet or 10 sidewalk squares is all you need is a cup of salt. We know winter is coming. And I think we've seen many times, you're like, wow, I am crunching on what has to be 5 cups of salt under my feet right now. So folks tend to go a little heavy with it. We're trying to promote people doing that less. We have pledges for pet waste and keeping litter in your car. Not that I think any of you are littering necessarily, but we've got little bags for your car that can just help you have a place to keep that. We've got the picture on the bottom left, the catch basin. I encourage all of you when you get home, take a look at the catch basins around your property. A lot of our municipalities are required to do the maintenance for that, but there are thousands and thousands of catch basins in cities. It can be very hard for them to keep up with some of that, including on a timely schedule when they're also trying to give you other services like leaf collection or waste collection or whatever it might be. So please safely, if you choose to do this, maybe clean out your catch basin. It takes minutes to just pull out some of the leaves and debris or trash that may be in there. And it really makes a difference in helping improve the quality of water that's going to our streams and other roadways. Additionally, you can also get involved, get out there. We do a number of stream cleanups and other types of outreach events. So we can definitely get you connected. You can sign up for our e-newsletter and find out when these events are happening. A lot of them probably aren't going to be until spring, as we are now heading into the winter season, but gives you lots of time to plan and prepare for it. Maybe think about your lawn too. Plant some native plants there, try to shrink it. It's less grass that you have to mow. What are you doing with your leaves? Maybe you keep them in your garden beds rather than putting them on the curb or bagging them up. We do some tree giveaways every now and again. We would love to see more private tree plantings. And I think one other piece that isn't sort of listed in here, but you can also be advocates. We really encourage folks to kind of speak up. So we've seen maybe ordinances that are protecting trees. So if you're doing new development, you need to make sure that those trees that are being taken down are either protected or replaced. So speaking to your city council about that kind of stuff. If you need maybe some support in what that policy should look like, that's something that we can help you with. It may take some time, but we can definitely work on that as well. And then with that, I just want to thank you and turn it over to Judy, because I know you've also got.
I just want to remind our virtual audience that there's a Q&A box and you can put your questions in there.
Yeah. Right.
I think you're good to go.
Thank you, Ed. Good morning. Thank you for having me. It's a very, really, I feel honored to be a part of this water forum. So my work today, I'm going to talk about 2 aspects. Firstly, we're going to talk about the water contamination in general, and then specifically harmful algal blooms in Lake Erie, because it's close to home. This is a quote I learned a few years ago from one of my former PhD students. I really liked it the first time I saw it. Thousands have lived without love, not one without water. I feel this is a very powerful way to say water is very important to our daily lives. But I also want to say it from engineering perspective, because this is 14 grand challenges of engineering in 21st century being issued by the National Academy of Engineering. So there are a few ones you might have heard of, where you have like a carbon sequestration, which is to remove CO2 from water, from atmosphere. We have like manage a nitrogen cycle. We are part of this large center funded by the National Science Foundation to recycle nitrogen from waste all the way to become fertilizer to be applied. But particularly to our interest is this one, provide access to clean water. Of course, clean water means different things to different audiences in, around the world, because they all have different economic development levels. We have all different local water resources. Water is a very local thing. But one thing in common is they all have certain contaminants or pollutants in them that need our attention. So firstly, I will talk about water contamination in general, and then I will give one example of harmful algae blooms in Lake Erie. Here are 4 examples of contaminants. Some of them you are more familiar with, some of them you might not be. The first one to the upper left is an agriculture field. So we tend to apply large amounts of pesticides to agriculture field. And after that, then there's rain coming in, the pesticides end up in the runoffs, and the runoffs eventually will be going into the receiving water, either surface water or groundwater, and cause pollution. The second example is a fire that represents fire retardants. In fact, fire retardants are almost in everything we touch in our daily lives. We're holding cell phones, the laptop, the fabric, the furniture top, coatings on the wall. Everything has a fire retardants in it. The third one, the lower left-hand side to the left, that's pharmaceutical compounds and personal care products, including antibiotics and hormones we take, or for farm animals. I was quite surprised many years ago when I first learned that majority of the medicines we take really are not metabolized, and they're extracted out of our bodies, becoming waste. The same thing happens to animals. So these chemicals are still very active. So they're going to be very active even at a low concentration in the surface water and groundwater. These 3 examples I show so far, they are all something called organic compounds. I don't know how many of you remember your AP chemistry in high school, but these chemicals can be eventually destroyed and become CO2 and water. The last example to the lower left-hand side, right-hand side, those are different heavy metals. These are inorganic compounds that cannot be destroyed, so they have to be handled differently. Examples would include lead. You might have heard of lead in drinking water many years ago in Flint, Michigan. This is one example, but there are many other heavy metals, such as mercury, cadmium, etc., coming from metal industry, coming from mining and other industries. So we really have to treat these different types of chemicals differently because they have to be treated differently, they behave very differently in the environment. Just throw in a few numbers so that you kind of appreciate the size and the quantity we're talking about. Firstly, there are over 850,000 chemicals that are environmentally relevant. These have been registered in the US EPA's database. Among them, some of them are used at very large quantities. For example, pesticides, 1 to 2.5 million tons a year, mostly in agriculture. For fire retardants, about 2 million tons per year as well globally. For antibiotics, the amount is about 162,000 tons in China, which is about 50% of the global consumption. In the US, it's about 22,700 tons. So we're talking about huge amount of chemicals being used on an annual basis. Some of them will end up in the environment causing pollution. But what are the potential impacts? Those are 2 numbers probably are the extreme cases where they actually cause disease, death. So the first number is for synthetic chemicals causing about 1.6 million deaths in a year. The bottom one was just reported a few months ago in a journal called The Lancet. They report about 5 million deaths associated with something called bacterial antimicrobial resistance. I know it's a multiple term. What it says is we have a lot of antibiotics, and the bacteria are actually trying to develop resistance to these antibiotics. And then when we get infected, our body loses ability to be combating this resistance anymore. So basically, our disease cannot be cured by antibiotics. So it's a very serious issue there. Luckily, we do have ways to mitigate the impact of wastewater mitigation in drinking water and wastewater. I'm showing one flow chart that is common in a conventional wastewater treatment plant. So I know that the chart might be messy here, but what you can see is the wastewater comes in, it's being screened to remove the large particles. And then in the second part, we have settling where this still decent sized particles are removed. And then we move on to this core biological treatment where these microorganisms grow, they kind of eat up these organic pollutants in this part. And lastly, we have this secondary settlement where we have additional removal of those biomass, which are microorganisms and other particles being formed. and then this water is discharged. But this conventional treatment cannot remove a lot of trace contaminants I showed early on. So if we want to do water reuse, which is probably not common here because we're so rich in water resources. But if you go to dry states like Arizona and California, they really rely heavily on water resource reuse. So you can see there's a long chain of treatment that we have to go through. I'm not going into details because we're not running enough time here. Just want to give you a general idea that there are many technologies needed to remove different kinds of contaminants, right? Each step here is a different treatment process. And even after this, we cannot guarantee all contaminants have been removed. So essentially, this is a very costly process. The more pure we want the water to be, certainly the more money we have to invest and the more technology we have to develop. Unfortunately, even after this, we still have a lot of contaminants being released. So the thing I showed earlier is something Kristin showed as a point pollution. We know exactly where the waste is, we can treat it. But for non-point pollution, for agricultural runoff, as example, we don't even know how to handle that, right, more efficiently. So this is a pioneer study done, I think reported in 2002, exactly 20 years ago, by the US Geological Survey. They went out to take samples from 130 streams across the US. You see those blue dots, each one is a sampling site. And they measure different trace contaminants. I mentioned some of them earlier on. So it turns out over 80% of those water samples were tested positive in some type of contaminants of concern. So really not a trivial question. So the question is, with all these contaminants in the environment, we have to assess their risks, right? What are the risks to the human health? What are the risks to the environment? To this, we have to divide the environment usually into air, water, and soil sediments. In each part of the environment, we have to evaluate the risks of these contaminants. I'm going to take pesticides as an example. I do recognize this is also a busy picture, but I'm going to walk you through that briefly. So we're going to take pesticides as an example. Once the pesticides are released, the volatile part will be ending up in the air. And then the sunlight comes in, very powerful energy input. That's going to help degradation of these contaminants. We call that photo degradation. But the majority will be coming down with precipitation into either water or soil. In water, then there's water facilitated degradation, and then the chemicals will go up the food chain, right? You have small fish taking the contaminants, and the big fish eat a small fish, and then, you know, et cetera, et cetera. This is one thing. Once the contaminants end up in soil sediments, they can be absorbed by crop, they can adhere to soil particles, they can go through this surface runoff to end up in the surface or going up the plants. They can leach into groundwater. They can also be degraded by microorganisms in the soil. So the idea, again, there are many processes occurring for each given contaminant. It's definitely a lot of work for us environmental engineers to go through each chemical individually in each environment. Basically, it's tons of work. So how do we make this process more efficient? Because we deal with thousands of chemicals in many different processes. So it's a general research area that we want to have models available without we have to run each experiment separately, which is extremely time consuming. And so this is really one of the focus of my research group. We're trying to develop these models that can allow us to predict the reactivity and the behavior of contaminants in different drinking water, wastewater treatment, and in different environments. In recent years, we have been using actually artificial intelligence, which I mean, some of you might have heard of, but that's something I don't have time to go into. I'd be happy to talk about it later on if there's any interest. Now, moving on to the second part of my talk, harmful algal blooms in Lake Erie. Most of you are probably familiar with this map. This is Great Lakes, 5 Great Lakes, and Lake Erie is only one of them. But Lake Erie is the shallowest among the 5 lakes. It also the smallest in terms of volume. Because of the reasons, Lake Erie is more susceptible to human activities. So if you have the same amount of contaminant discharged into the lakes, because the small volume, because it's so shallow, the water quality is impacted to a much higher extent than the other Great Lakes. This will be one of the main reasons why we see harmful algal blooms in Lake Erie more often. But in general, there are about 34 million people living in the Great Lake region. More than 1/3 is living in the Lake Erie Basin. In addition to providing drinking water to support the fishery, Lake Erie is also supporting a 11.5 billion tourist industry. So Lake Erie is really very important to the local economics. However, Lake Erie has consistent harmful algal blooms in the past few years, which really concerned a lot of the public, the human health, and also even for local economy. So what is harmful algal blooms? Some of you might have seen some of the photos on the internet. You have seen this green, blue algae or cyanobacteria for the official name. Basically, during the warm months like the summertime, this algae will grow intensively. So they will cause fish dying. We have this very intense water being contaminated. There are toxins being released. This algae grow needs a lot of oxygen. So they're going to take up majority of the oxygen in water, and there's not much oxygen for other aquatic species to grow. So it's a series of consequences for these algae blooms to occur. So the first question we had was, so what is the cause of these algal blooms so that we can mitigate from the source? And here's a satellite image. You see in the central and the eastern part of the lake, we really don't have any algal blooms. In the western part, you see there's a very dark green color. That is very severe algal blooms being occurring. In fact, this is one of the worst times in 2015. That's the satellite image showing that. So why is the western part of the lake more severe in terms of algal blooms? Studies have shown that that's because of the Maumee River watershed. So here's the map for Maumee River watershed, which flows in about 18 counties. And in this area, about 72% is for agricultural usages. The main crops growing include corn, soybean, hay, and wheat. And we know that crops need a lot of fertilizers. And the fertilizers, once they are applied to the agricultural field, it turns out majority of that actually is being washed off into the runoffs because we have so much rain very often, very heavy rain sometimes. These runoffs will follow this flow path, eventually enter into the western part of the lake. So that tends to be the major reason for the algal blooms to occur. So one of my ongoing research right now is to try to see, can we develop any low-cost materials and technologies that can help mitigate the contamination in the runoff. So we can eliminate fertilizer from the runoff so that we're not contaminating the lake from the source. Another question would be, well, before we have a good treatment in place, we would have to have monitoring of this algal bloom occurrence on a regular basis, right? We have to know when the blooms will be the worst so that the municipalities are ready, the public is ready. So there are basically two types of models currently being used by the National Oceanic and Atmospheric Administration. NOAA has two models. The one I'm showing here is the first one. That's to predict the severity of the blooms. So those are a series of satellite images I'm showing here. Each one is for the worst bloom in each year. You see in 2002 or all the way to 2006. The color means more intense algal blooms. The red color means the most severe blooms. The blue means lighter blooms. But in general, in early 2000s, the blooms are not too bad. In 2007 to 2011, we have some worse blooms in 2009, but still not too bad. But you see 2014, 2015, we have very severe blooms. So NOAA basically, based on these images, they kind of develop a model that can estimate the bloom for the next year. So this is the one, they quantify the bloom extent for each year on a scale of 0 to 10. The lowest one between 0 and 2 is light, 2 to 4 is mild, 4 to 6 is significant, and above 7, 4 to 7 is significant, above 7 is severe. You see in 2014, where we saw that no water to drink alert by the city of Toledo, very severe bloom. But on this scale, you can see many other years we have even worse blooms in the history. So we definitely have some very worse blooms in the past. But this last bar here shows the model predict the bloom severity for the current year. This was issued, I think, sometime in June or July. So they kind of say what's the worst bloom of this year. This is a photo we took from the lake, I think the end of August. So this is the concept of minor blooms, which agrees quite well with the predictions here. So the model worked quite well, but this one only for annual severity. And then NOAA has another model that can predict a more real time. This is for 96-hour forecast. So you see there's one set for 2017, the second set for 2016. So in this model, they treat this algae as particles and monitor the physical transport based on the water flow and the wind speed. So you see that these colors change. That means the bloom is being moving because of the water current. 2017 is more severe than 2016 on the bottom. So we definitely have a milder bloom in 2016. And here is a snapshot we took early in September of this year. You see there's only some mild bloom on the western end of the lake. The rest of the lake is pretty safe. So this seems to be working quite well. But the downside of this model is that it only relies on the physical movement. It doesn't consider any information, biological, physical, or chemical mechanisms. So one of my projects right now is trying to, again, using artificial intelligence, trying to develop more intelligent models using the real mechanisms. And that's all I have to say, because I just want to give you a general over idea of what we're concerning and what we're working on. And I'd be happy to answer any questions. Thank you.
Okay, thank you both. We're in our Q&A session. For those that are present in fellowship hall, I ask that you respect Debbie Wright. She's one of our committee, and she will carry the microphone. She will select people. Please hold up your hand if you have a question. For those people that are virtual on Zoom, as Jean mentioned, there's a Q&A button. Please enter any questions that we have light. It must be a miracle. In addition to that, we have a chat box. So if you haven't already signed up for our email and you'd like to be notified of future forums, please enter into the chat box. So with that, Debbie.
I thank you, first of all, for a wonderful presentation. I have one comment, one question. The comment is I like to hike in the metro parks. And in the past, Bedford Reservation, when I'd be on the rocks, there were tomato plants growing all over the place because clearly human waste had ended up in the river that goes through the reservation. That has not happened in recent years. And also the fish population is visible. So I know that whatever you're doing is working in that. I have a friend who's an environmental lawyer in Washington, D.C. And he told me once that much of the water rights of the Great Lakes, especially Lake Erie, have been sold, sometimes to other countries and people in other countries. How much of the lake actually belongs to the public, both America and Canada, and how much belongs to other people who have bought water rights?
There's something about the Great Lake Compact too, so comment on that too, maybe.
Yeah, so as far as I know, and I am definitely not an environmental lawyer, you can buy water rights to take water out of the lake if you are using it for some sort of we'll say commercial purpose, but as far as I know, that you need to be then situated within the Great Lakes Basin in order to use it, so that any waste that's sort of coming off or water runoff, excess water that is not used goes back into the watershed. Under the Great Lakes Compact, no one can take water out of the Great Lakes region. And as far as that would be something that I would very much work to advocate as far as I know,
It's been broken once.
yes. And I think there was something, I don't know the exact timing, but fairly recently, it was reinforced to strengthen those protections of removing that water.
Thank you.
Mhm.
Yeah, it seems to me phosphates are always blamed for the algal blooms. What about nitrogen? And farmers are resentful because they say, people use all these lawn fertilizers, but we don't hear about it. The farmers are always blamed. So
Yes.
He's a farmer.
I don't blame you at all because I know phosphorus has always been blamed, but recent studies have shown the nitrogen. We have to consider nitrogen as well. So in fact, we just have this center be established, being funded by the National Science Foundation, 26 million over 5 years, to understand nitrogen. Of course, Lake Erie is only part of that. But the reason we increase in nitrogen, firstly, nitrogen, phosphorus always used together as fertilizer. So we cannot just blame one, not the other. And secondly, we have little understanding of how nitrogen contributes to the Lake Erie algal blooms. There's some evidence showing others are not, so it's very conflicting as a point. We're working with this model for the past 2 years now, and our studies show that the nitrogen is actually very important in causing blooms. Not by itself, but in coupling with phosphorus. Both of them should be very important. And what you're saying that, we're looking at agricultural fields only. Of course, we have so many lawns individually for the family houses. We use a lot of herbicides and other things. But that's really like Kristin showed earlier, that's non-point sources. It's much harder to control and much harder to really quantify the extent. It's interesting, I heard many, a few years ago, like well-educated people know exactly what happens to their fertilizers, but statistically, they actually use more fertilizers than the general public. So it's hard, the education part is also very important. We kind of tend to overuse the fertilizers of lawns, that might be another educational component.
Yeah, I would
Yeah.
say just to build off of that, one of the things that we try to do is encourage you to test your soil first, because there's lots of science that will then tell you what exactly you need to apply. I know in those more rural areas of Western Ohio, soil and water districts and other agencies at like Ohio Department of Agriculture are working with those farmers to be a little bit more proactive in how they're applying some of that. So then hopefully Judy's job trying to manage what's running off of that gets a little bit easier because you're doing the kind of right application. And then same thing at your home. You can do some of those soil tests and you may not need to put that much on. It's just kind of the right recipe to do so.
I want to follow up just a minute. So it's not just what you put in this year, because this fertilizer, these nutrients are accumulating in the sediments, in soil, in lawns. And that turns out to be very important as well. So even if we stop putting any fertilizers for this year or in the next few years, it doesn't mean the blooms will go away. It just these legacy, we call the legacy nutrients, will actually still be playing a big role. Yeah. So both things we have to consider. That's why it's so hard.
Okay, I just want to say something about government regulation. It used to be that the Food and Drug Administration had more staff to really monitor some of the prescription kinds of drugs for adverse effects. That's been cut back. And a lot of people don't realize that when they buy over-the-counter supplements, there is no program that really monitors whether they are safe or not. The FDA does not address that at all.
Yes, yes. Thank you. That's a very important aspect we need to talk about. So I actually worked as a postdoc at US EPA National Lab for 3 years before I became a faculty member. So I kind of know what's going on. Well, that was 15 years ago. And ever since then, I think there's always a downsizing at the EPA. So it's kind of frustrating, but it's very political. Really depends on who's in the government, how they view the environmental issues. But I know a few years ago, the lab I was working at, we were asked to downsize by 50%. 50%. So that's a serious issue in terms of like who is regulating and what is being regulated, right? FTA, I'm not too sure, but I'm sure your observation is going to be very much similar. We don't have enough people to, firstly, there's so many chemicals we have to deal with. What should be regulated? What level should we be regulating? I will give you one example. So I have a few friends working at the Office for Pesticides at the EPA. They're regulating both existing pesticides and any pesticides being either imported or being just newly released to the market. So there are two different offices in the same kind of domain. So what they need to do is, firstly, for existing pesticides, they have to evaluate how toxic they are and what quantities are we going to be using, especially for the new ones or the ones being imported. Should they be even being released to the market? So they have to scratch their heads to find out, are they toxic? They have to go through, like, say, 100 pesticides in a week. Those are all new chemicals. We don't have any their study data for. So they have to rely on very limited information to make a judgment. You can see, really, we are lacking of manpower. We also have lack of scientific research to support that kind of decision. So I'm very much echo what you are concerned about. We need more investment. Of course, as a researcher, I'd always want to see more research dollars coming into the space. But that's the reality. There are more other priorities, right?
I think I just build on that where she said it's very political. I would say there are unfortunately larger priorities that are just perhaps taking the EPA's focus compared to some of those others. And in all honesty, if we watched, turn on the TV right now, how many various drug commercials are you going to see? Those industries bring a lot of dollars, and it's in their best economical interest to make sure that their products get through. So they may not have the same level of, FDA may not even have the protocols to understand. I think they're looking at the effects of humans. So what are the side effects for me taking the drug? They don't have the capacity to think about what is the end use after we release those, because again, your body's not using up all of them. I've seen some researchers starting to get some data on fish and their impacts from the hormones that they're seeing from waterways. And I think it's building that case. And the more that we have that, and again, going back to, those Dust Bowl and river fire pictures, we really hope we don't have to reach a big critical event that then is going to lead to that. We're trying to be more proactive, but I have not seen it be the highest priority, unfortunately.
But I do want to add some positive note.
Yes.
We're not doing everything bad, especially US and the more developed countries. We have more regulation in terms of the prescription drugs like hormones, antibiotics. If you go into some developing countries, there's no regulation at all. So basically, you can buy those antibiotics over the counter and use it without any regulation. And with people are increasing the population, with their living standards being higher, and they tend to eat more meat, you can see the increase very much highly in the number of antibiotics and other prescription drugs being used. And it's going to be getting worse in other countries. Yeah.
We have a couple of questions online. The first is from Jim. He asks, should we be using filters on our water faucets? And should we also keep our water in containers with filters?
I'll speak to that. And this may be from my previous life coming from the city of Cleveland. Cleveland water is some of the best water in the country, if not the world. I don't use a filter. I drink tap every single day. I love it. I would say, I don't know where you live, Jim, but if you are serviced by Cleveland water, I have a high degree of confidence that your water is going to be safe and healthy. And I don't think there's any need to utilize a filter. But I also, that is me. I am just speaking for myself. So if you feel that you need to use it, please go ahead. But I have no concerns about the safety of our water or need to store it in any way. You should be good.
Yeah.
I mean, there's an emergency preparedness component. It's always good to have some water on hand. As much as, we have great infrastructure here, we are still just as at risk of some of these harmful algal blooms. If one gets really severe, Cleveland, while we are further east, we don't have to, it's not as pressing of an issue here, but it doesn't mean that we are immune to it either, and that we would not be able to be impacted by that. So
I very much echo what Kristin just said. I drink just faucet water as well. I visited both drinking water treatment plants and wastewater treatment plants in this area. They are very, very well equipped. They have very high technology. You know, they are really the best, among the best in the nation. So I have no doubt in their quality.
and if you get the chance, I highly encourage you to go take one of those tours.
Oh,
Both
yes.
organizations do open houses, and it's humbling to see what it takes to provide the clean water that we have to so many people. It's we're very lucky here. And I think that's what I don't want to say in this room, but some folks maybe take that for granted because we can turn on the tap and have, just such great water coming through. I've been to other places throughout the country, and I try their water, and I see, okay, I guess maybe I get why people drink bottled water. It's got a little taste to it, but we've got some great stuff here.
There's another online question. Some cities and townships are using brine from oil and gas drilling waste as a de-icer. The brine is said to be radioactive. Is this one of the contaminants that are monitored by this county or state?
Not currently, unfortunately, and it's something that one of our board members has actually brought up as well in some of his other work. They've been looking at some of that. I mean, we work very closely with our municipalities just to encourage less salt use altogether. And I think we have not had many in Cuyahoga County that are utilizing that specific brine that you're talking about. So it has not been something that we've really had to focus on. But if we find that it's popping up more, it will be something that I think we need to do a little bit more research and understand what it looks like. But we are not supportive of putting anything radioactive on our streets.
Yeah, I don't know about this particular brine, but a few years ago, I had a research project from the Pennsylvania Department of Transportation, specifically evaluating 5 different de-icers, compare them with the commercial ones. Very interesting study we did probably 2 years. So we evaluate on side, one side is the performance, like how well they can de-ice on different temperatures. On the other side, we also compare the toxicology side, the impact to the environment. The performance-wise, certainly their performance is better, but the cost-wise is more expensive than just the salt we use. For the toxicology, with the ones we tested, none of them tend to be much more toxic than the commercial ones. But of course, it really limits to what the brands we tested. So the ones we tested, the 5 of them were all pretty good. And one of them was from these fracking wells. Yeah.
So in our region, there are so many threats to water quality and sources from where they come from. And we know climate change is only going to ramp up these problems. What do you see as some of the biggest threats in the next 5 to 10 years? And what is being done to help address these threats?
Yeah, sure. So climate change, I'm not a water person, but in the last couple of years, I definitely see the need to look at climate change more often, so that I have 1 or 2 students actually now working on direct capture of CO2, because we definitely see a huge interest or huge move and see how climate change, like yesterday was 77, right, in November. That's really unheard of, but that's going to be more often. It becomes a new norm now. And one reason is because we have these greenhouse gases being discharged to the atmosphere. Just following the current practices, we're not going to cut down the CO2 emission. We're going to probably slow down the release. It's just the speed is slowing. It's not the amount being slowing. So we're going to still be in an upward trajectory in the next couple of decades at least in how much CO2 is being released. So things are not getting any better. So we do see the need to have technology ready. We can directly capture CO2 from the atmosphere, so we can somewhat lower the levels over time. Right? That's what we're seeing as the need. But in addition to CO2, we have other greenhouse gases like methane, natural gas, and then we have other lower level we have to deal with. I think there are 2 major research areas we have to look at. One is at the industrial scale. If we have a power plants, we have other manufacturers direct release CO2 at a larger scale. How do we remove them? And then for the more broader scale, for direct capture, which is really even in the infancy level in terms of technology development. So we have a long way to go, but it has to be paired with policy as well, because that regulates what the industry is releasing and how much industry is releasing. That's a little bit beyond my research area.
And I think maybe just to piggyback on that, on the CO2 side. So we are the Soil and Water Conservation District. I think many of you would probably agree here in Northeast Ohio, we're pretty good on the water. We had burning water and now people can kayak on the Cuyahoga River and our fish are coming back. We're doing pretty well there. The part that gets me a little nervous is the soil side. And remember the pictures of the Dust Bowl. I don't feel, especially here in an urban area, that we maybe appreciate the soil that is underneath our feet. And as it relates to climate change, we were expecting to see warmer, wetter, and we're used to wet weather here in Cleveland area, but it's going to probably get worse and then weirder. So we're going to see these 77 days. We're going to see huge storms in June that we weren't expecting. And that water is powerful. It can really have an impact on the ground beneath us, erosion, runoff, all of that. What does a better job of holding water, sand or a lush forest with really healthy soil? So I think what Soil and Water is going to be working on over the next year is figuring out what is our role in replenishing our soil here in the region. And a lot of that is, for me, organic waste management. If we're cutting down trees and capturing leaves, we need to be putting that back into the ground where it comes from and not shipping it outside of our region. So that's an area that I'm very excited about. And it has carbon sequestration potential too.
Do we have time for one more
Yes,
question?
one more question.
We'll be quick.
I was wondering about those long tubes you mentioned that absorb water runoff from like construction sites and things. And are they filled with just absorbent material for water, or do they have any kind of chemical binding properties like activated charcoal or something? Can they be saturated and not reused at that point?
So they are mostly compost and mulch. So no kind of chemical additives to it. And really they're just helping to hold and slow the water and do a little bit of filtering as well as it runs through. We see a lot of them just get repurposed on the same site if they can, or they get taken off and may get composted again. But no, there's generally not any additives to it.
Okay. Thank you both. A few announcements, but first of all, I want to thank both of our guests, which we just did, about clean water begins with individual action, so don't fertilize your lawn. Okay.
Come see us, we'll tell you what you can do.
On November 20th, that is not next Sunday, the following Sunday, we're going to have a topic, labor shortage. What is the future in Northeastern Ohio and beyond? For all of us here, as well as Zoom, you're invited to the church service upstairs. It's live streamed, by the way, on Facebook and YouTube, and it'll begin at 10:15 with Dr. Reverend Parting. His service topic is that broken thing. And what that means, the bottom line is, how do we accept change where there's an opportunity to grow? So with that, thank you again.
Don't forget to vote.
Oh, yes.